Hey there. Today we are going to talk about sequences. Now, sequences are really just a list of numbers. They're separated by commas. And there's a lot of different notations that we might use to signify that we're dealing with a sequence. So we might name a sequence using this notation here where I call it A sub n, and I might put curly brackets around it. I might actually list out the terms. In a generic one would be A sub 1, comma, A sub 2, comma, and then if it's a long one or we're skipping some terms, not writing them all out, we'll have the dot, 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 which is an ellipses. And an would be the nth term, and so on. So the first term of the sequence is a sub 1, or just a1. Second term of the sequence is a2, and so on. The nth term is an. The term that comes after the nth term would be a sub n plus 1. And when you're writing these things, make sure you're being careful with the notation. You don't want a sub n plus 1 to look like a sub n plus 1. So make sure that subscript looks like a subscript when you are writing out these general terms. Some other notations you might see is maybe I have the a sub n with curly brackets, and then outside I'll have n equals 1 and then an infinity above it. And so that's telling me that this sequence starts at n equals 1 and goes on forever. Another way I might write it is I list out the terms A1, A2, A3, and so on, and then put curly brackets around it. All of these are notations indicating a sequence. In general, the characteristics of a sequence is it's an ordered list of numbers. We're usually looking for patterns here. It acts much like a function whose domain is just the set of positive integers. So you'll see I have, A1, A2, A3. There's no A 1.5 or anything like that. It's only positive numbers or positive integers that we're plugging in. These can be finite, so maybe they have a definite start and end, or they can go on forever and be infinite. Now, something that we run into when we start talking about sequences are factorials. And there's a good chance, unless you've done some statistics, that you've never seen a factorial. So it is an exclamation point that we use for a factorial, and we write it after a number, and it would be read as, for example, here, n factorial. Or with a real number, it might be something like 5 factorial. And what a factorial is it tells me that I'm going to take that number, whatever n is, and I'm going to multiply it by all of the positive integers less than it, everything that came before it, all the way down to 1. So 5 factorial would be 5 times 4 times 3 times 2 times 1. And if I multiply all that out, I get 120. So that's what a factorial means. If I did 10 factorial, that would be 10 times 9 times 8 times 7, all the way to 1. Okay. There is a factorial key on your graphing calculator, or most scientific calculators will have a factorial key. It's usually under a probability menu if you're looking for it. And definitely that's something that you can email me about if you can't find it, or if you're in my in-person class, we can find it in class together. Now, some other facts that you might want to be aware of with factorials is 0 factorial, as weird as it might seem, is 1, as is 1 factorial. So if you run into those, that there's no issue there. Both of those are going to be equal to 1. Okay, so let's do some examples an example with sequences. So first thing we want to do is get comfortable just with understanding the notation and understanding how to find terms based on the nth term. So here we're being asked to find the first 5 terms of the sequence whose nth term is a sub n equals 2n minus 1 over n factorial. So the notation is different. We're not using x's or f of x, but really it's the same thing as evaluating a function that we're being asked to do here. We're just being asked to do it for only the whole numbers. And here we're going from 1 to 5. So I'm literally going to take this nth term and plug in 1 and simplify it, then plug in 2 and 3 and 4 and 5 and get the first 5 terms of this sequence. So this nth term is just describing the pattern for finding any of the terms of the sequence. I could use it to find the 100th term of the sequence if I wanted to, simply by replacing the n's with 100 and simplifying. So an would be, or a1, would be 2 times 1 minus 1 over 1 factorial. Again, I just replaced all the n's with 1, and then I'll simplify that. So 2 times 1 is 2, minus 1 is 1, divided by 1 factorial, which is also 1. I just get 1 for that one. For A2, I replace the n's with 2. So 2 times 2 minus 1, that would give me 3 over 2 factorial, which is 2. So 3 over 2. For the third term, 2 times 3 minus 1 would give me 5 divided by 3 factorial, which is 3 times 2 times 1, so 6. So 5 over 6. For the fourth term, I get A4, which would be 2 times 4 minus 1 over 4 factorial, which would simplify to 7 over 24. Again, feel free to use a calculator for this. Just enter everything in carefully. And the fifth term, 2 times 5 minus 1 over 5 factorial, well, that would give me 9 on the top and 120 on the bottom, which does reduce to 3 over 40. And that's how you find the terms of a sequence. And if I were to list these out using the curly brackets, my sequence looks like 1, 3 halves, 5 6, 7 24ths, 3 40ths, and so on. Now, there's one special type of sequence that we want to talk about before we move on to the next section, and that is recursive sequences. A recursively defined sequence means that to find the next term in the sequence, I have to use previous terms. Okay, so they're a little more complicated to find terms versus like the last one we looked at, where I just had a formula. I can plug in a value for n, and I know what the 10th term is without having to find all the terms that come before it. But with the recursively defined sequence, you need to know what some of the terms are that came before it in order to find the next one. And so here's an example of a recursively defined sequence. I've been told the first term is 3, and then the rest of the terms are defined by this nth term, which is an minus 1. So that's the term that came right before an, minus 2 over n. So a little bit trickier for these because I have that a sub n minus 1. So it's calling back a previous term, the one right before it. So I have to know the term that came right before. So like if I wanted to find the 10th term, I need to know what the 9th term is to plug in for an minus 1. So let's give this a try. We want to again find the first 5 terms of the sequence. So well, they gave me the first one. A1 is 3. And that will allow me to find the others. So that is a big tip off with recursive sequences, is they're going to have to give you at least one of the terms, maybe more, depending on what the nth term looks like. So A2 would be a n minus 1. So 2 minus 1 is 1. So A2 equals A1 minus 2 over 2. And well, A1 was 3. So 3 minus 2 over 2 would give me 1/2. And now I'm going to use that 1/2 to find the next term of the sequence. So A3 would be A2 minus 2 over 2. So that's 1/2 minus 2 divided by 2, which if I plug all that into my calculator and simplify, I get negative 3/4. And now the 3/4 can be used to find the fourth term in the sequence. So A4 is going to be A3 minus 2 over 2. So negative 3/4 minus 2 divided by 2. Plugging all that in, I get negative 11 over 8. And then I can use that to find the fifth term that they asked for. So A5 is equal to A4 minus 2 over 2. So negative 11/8 minus 2 divided by 2 gives me negative 27 over 16. So that's how you work with a recursive sequence.